everyone. My name is Lourdes Morillas, and I want to share with you the results of this experiment about the assessment of epiphytic lichens vitality when subjected to high radiation and nitrogen pollution. So these are the 6 species of lichens that we have used in this experiment. We can classify them in different functional groups depending on how do they respond to a given environmental stressor, being Xanthoria and Ramalina the most resilient ones to nitrogen pollution, and Usnea and Palmotrema the most sensitive ones, whereas Flavoparmelia is the most sensitive to solar radiation. So this differential behavior allows us to use them as a monitoring tool, right? For example, in this study here, the authors established the critical lows of nitrogen deposition by analyzing the lichen functional diversity in a semi-natural Mediterranean coral ecosystem. To assign a lichen species to a given functional group, we rely on data describing its response to different environmental factors, such as nitrogen pollution or solar radiation. But despite the great numbers of studies considering individual environmental factors, the synergistic effect of these factors on lichens' physiological response is extremely scarce, even though they are vital to get a comprehensive understanding of the effect of global change. 2 of the most challenging drivers of global change are the increasing values in both nitrogen deposition and temperature. So our hypotheses were that the different species would differ in their response to these environmental factors because of their special adaptation strategies. Namely, we expected that the most tolerant species to each one of these environmental stressors would be the most resilient to the synergetic effects of them, right? We also expected that the physiological response of lichens to increase solar radiation would be modulated by the nitrogen addition treatment because they cannot buffer their nutrient content. So we exposed 6 species of lichens belonging to different functional groups to 1 daily dose of 0 in yellow, 25 in green light, and 50 in dark green millimoles of ammonium sulfate during 57 days. And in the day 21, where you can see the green arrow and the sun, we exposed them to direct sunlight, which involved both high temperatures and ultraviolet radiation. To test our hypothesis, we used chlorophyll A fluorescence as a sensitive but non-destructive method to assess the response of the photosynthetic organism to environmental changes. We found that for all species and nitrogen treatments, the sunlight exposure implied a drastic decrease in their physiological performance. These results also reveal that for all species, the physiological response of the lichens to increased temperatures was modulated by the nitrogen addition treatment applied to them, which highlights the relevance of studying the interaction among global change drivers. These findings shows on one side that the synergistic effects of multiple stressors can impact sensitive as well as tolerant species. And on the other side, they indicate that controlling local environmental drivers, such as nitrogen input, we could mitigate global change effects on ecosystems. That's all. Thank you very much.